everyone, before I get started, I'm going to ask you to once again clap. Give another big round of applause for the organizer. I'm very excited to be here. Simona Cotin, developer advocate at Microsoft. You can find me on Twitter at Simona_Cotin. If you have any questions regarding JavaScript or machine learning, Node, Angular, anything, do ping me. I'm happy to chat with you. So let's get started. Episode 1, machine learning. You're right. All right, you're right. OK, fine. OK, fine. Yes, right here. No, not right now. No, not right now. Talk to me right now. Please talk to me right now. This is a poem that has been generated by AI. So a team of scientists have wrote an algorithm, and they fed thousands of unpublished novels to this algorithm. And they've created a model that can go ahead and generate new novels by just starting with 2 words. And these are romantic novels, in case you didn't notice. So this is AI's perspective on love based on what we've created so far. Another interesting project that I highly recommend you check out is the next Rembrandt. Another team of scientists have sat together and they've basically collected all the paintings that Rembrandt has created, and they've analyzed pixel by pixel the features and Rembrandt's style, and their goal was to create a new painting that would look very similar, that should kind of use Rembrandt's style. And this is the moment where I get to test you. How many of you think that the picture on your left is the original Rembrandt? Can you raise your hand? So we probably have maybe 20% of the room. What about the picture on your right? Maybe 25%? The rest of you, I would think that they're very undecided. They cannot tell the difference. And that's because AI is very good at generated art as well. And I'm going to spoil it for you. The picture on your left is the one that has been generated by AI. And it's been printed using 3D technology. Another cool project is called AI Weirdness. And researcher Janelle Shane, she's used deep learning to generate pickup lines. You are so beautiful that you know what I mean. This is how AI would kind of try to find a girl or a guy. I want to get my heart with you. I want to see you to my heart. You look like a thing, and I love you. Wouldn't that be great to hear? I recommend you check it out. She has much more interesting projects as well, things like how she worked to generate jokes and many other interesting things. But really, machine learning is all around us. When we type a query in a search engine, it's how the engines figure out what to return for us and what would be most likely that we are interested in based on our previous history. When we read our email, we don't see spam anymore most of the times. That's because we use machine learning to filter it out. When we're going to work, we're using maybe maps, and they're using machine learning algorithms to figure out the most fast way to work, the fastest route to work. Amazon and Netflix, they use machine learning to recommend us the best things that, well, maybe the best movies that we would be interested in, or some of the products that we might want to buy. Facebook uses machine learning to figure out what to show us first, and so does Twitter. So machine learning is literally surrounding us. And it's going to take over the world, for sure. And as web developers, even though it seems like it's an unattainable skill, my goal today is to show you that we can all get started with machine learning right here, right now. So I'm assuming that at some point, every person in this room has felt a bit like, this JavaScript developer. This is a meme that's been generated by a friend, Eleanor Haproff. She has amazing talks on machine learning. Go check her out and follow her on Twitter. And I bet that most of you felt like that earlier this year when TensorFlow has published TensorFlow.js. And TensorFlow.js is a JavaScript library for training and deploying machine learning in the browser and on Node.js. So with TensorFlow.js, we can run machine learning in the browser, on our phones, on our desktops, wherever. And this is an application that has been demoed when they published TensorFlow.js. It's basically a quick, fun app where you are being tasked to identify an emoji to match something in the real world that identifies emoji. And you are timed, and the more emojis you find in the real world, the harder your tasks will become. And this is all done in your browser. And the way you can get started with TensorFlow.js is as simple as importing a script tag or installing an npm module, which includes TensorFlow.js in your project. And then this is probably an example of Hello World with TensorFlow.js, where we basically initialize a model, and then we generate some random data, and from there we train that model and we predict new results. And there's a couple of key concepts that are important in TensorFlow.js. The first one is this concept of tensor, which is basically a multidimensional array. And TensorFlow.js helps us with methods so that we can initialize those. We also can run operations, and we have to run operations because machine learning relies on math to do all the predictions and all the training. And in here you can see that I'm using the square operation, but there's many other more complicated operations that are available for us, and they are being implemented in the library itself. So we just have to use them and know how to use them. And then the model is another very important concept, not only in TensorFlow.js, but also in machine learning in general. And a model is a function, a glorified function, mathematical function. And our goal in general when we're training with data is to identify the perfect or near perfection coefficients that we can use so that we can predict data accurately. But there's only so much we can do with machine learning in the browser. For models to be accurate and predict data reliable, we need to train them with large amounts of data. And for most cases, that typically takes days. I was just reading about this farmer somewhere in Asia that was basically training a model so that it recognizes different cucumbers based on their quality. And he took 7,000 pictures of different cucumbers. And in order to train a model using those pictures and his own personal computer, he has to spend days, several days, to do that. So imagine you have a new cucumber growing, and then you want to add it to the training data set, and you have to train that model again. It will take you several days using a normal computer. And that's where the cloud comes into play. We can leverage some of the resources that we have available in the cloud so that we can do all these training steps can be faster. And then with TensorFlow.js, we can actually take those models that have been created in the cloud and trained in the cloud. We can import them in TensorFlow.js, and we can use them on our phones or on our browsers to predict data based on what it's been trained to do, or what it's learned to do. And that's not our only option. So we can use TensorFlow.js in the browser, but then we can also leverage the machine learning as a service. And what I mean by as a service is we basically have these APIs that we can call, and they're going to help us predict values based on the models that have been trained by cloud providers or companies or products that have been specialized in this. And we don't have to necessarily work on all that mathematics. We don't have to be PhD students. We don't have to know tons about machine learning. We have to know the core concepts, and we have to know the steps that we need to take, but then we can leverage those APIs in order to add machine learning to our applications, also known as MLAAS. So with Azure Cognitive Services, we have access to all these APIs, like vision, language, speech, search, and knowledge. And all we have to do is call an endpoint, and we're going to be given results based on what the API thinks we are, based on our input. And this is an example of how we'd use computer vision. This is a picture of me using the jsPoland swag. And as you can see, I've uploaded this picture to the computer vision API, and it's returned a description for me with a set of tags, things like it has figured out that I'm a person, that I'm a woman, that I'm holding something, that I'm standing. It kind of thinks I'm a man as well, which doesn't flatter me, but it happens. It has figured out I have a hat, a phone, and I'm in a room, and then it's given me a caption. I'm a person wearing a hat with a confidence of 0.57%. And then the other tag is person with a confidence of 91%. And that's where we want, that's our goal, 100%. And this is a demo that I've built. It's called the Doppelganger app. Some of you might have heard of it. And for those of you who don't know what a doppelganger is, it's basically a person that looks very similar to you, but is not related to you. And this is an Angular application with a simple form where you can upload a picture, and then it will tell you a percentage, who do you look like most. And you've seen there that Sam looks 97% like her mom, and Burke looks 95% like Arnold Schwarzenegger. So in this app, I'm comparing faces to 80s characters. So we start with a machine learning algorithm. We feed in some data, and then we create a model, we generate a model. We feed new data into that, and we expect that to predict some results for us, so to give us a percentage of similarity. And our goal is to train a model that will match faces to 80s characters. So in this case, you can see I'm submitting a picture of myself, and it will tell me that I look 31% like Back to the Future. That's completely irrelevant. That was a model that really didn't work as good. So the first step is going ahead and gathering all that data, figuring out which are the 80s characters that I really want to include in my app, download pictures of those characters, and upload them in the cloud so that I can train my model. The second step is actually training the model. And then the final step is making that model available either as an API or maybe exported for a mobile application. So there's plenty of tools that you can use to achieve these steps. I've personally chosen to implement this using Azure Custom Vision Service, which is a tool for building custom image classifiers. And I'm going to show you very quickly how easy it is to get started. So this is the welcome page of my computer. And this is the other welcome page of Custom Vision Service. So the first thing that I need to do is create a new project. And if the internet gods work with us, we're going to get this done in like a couple of minutes. So I have to give it a name and then choose a resource group. And then it should create a new project called jsPoland. Otherwise, I'm going to show you an existing project. I've actually recorded this just in case things don't work out. This is signing in. This is the dashboard that you've just seen, giving a name to the project, a description, choosing a domain. So this is this application is using a model that Microsoft has created by training using a lot of data that we've created on the web for them. And now this is the dashboard where we can actually add more images and create some tags. So how this works is I'm going to upload images of Luke Skywalker, and then I'm also going to tag it so that we know that this is the name and this is the picture that we've created. And then we're also going to add a new character, which is Leia, and upload those pictures. And depending on how many pictures you're uploading, this is going to take more or less. Like this has been a couple of seconds. The requirement here is to have at least 2 tags and at least 5 pictures for each tag. And the next thing I can do is go into training, and it's as easy as clicking a button. And this is going to give me 2 metrics. The first one is precision, and that's going to tell us, for example, if we look at Luke Skywalker, of the pictures that have been classified as Luke, how many are actually Luke? And that's precision. And recall is of the pictures that are actually Luke, how many have been classified as Luke? So precision and recall. And that's what we use to assess the accuracy of our algorithm, which tells us whether our model is correct or not, will be able to predict things correctly. And then the next thing that we can do is actually go ahead and test this model that we've just created by clicking that button, and it will give us the 99% prediction that Burke looks like Leia. And what this tells us is that our algorithm is not doing, our model is not doing very well. And as you can imagine, that happens because we've only submitted 5 pictures and 2 tags, so we don't have enough data. And these are the concepts. So in our Angular application, what I've done is I've used the prediction API URL that I can copy from the dashboard itself. And then I'm making an HTTP request to that URL. I'm sending the prediction key as part of the header, but you can imagine in a world where you don't want to check in your prediction key on GitHub, you'll actually use something like serverless, where you're going to use a backend to forward that request. And then I'm sending the picture to the API, and it's going to return a prediction to me, a percentage, which is pretty cool. You didn't have to know almost anything about machine learning to understand everything that happened there. This is just an example of how you can build a doppelganger application, but you could also implement something like the not a hot dog application, where you can take pictures of things in your plate, and your very smart application will tell you whether you have a hot dog in your plate or not. And many other smart things. This is where you can find the app that you've just seen, aka.ms/80s. It's fun to try it out. You're probably going to look a lot like Arnold Schwarzenegger. My model seemed to be skewed towards that, but let me know. Another thing that, another type of API that we could use, it's called text sentiment analysis. And looking at this particular text, for example, I had a wonderful trip to Seattle and enjoyed seeing the Space Needle. I'm going to submit this text as a document to the text sentiment analysis in Azure Cognitive Services, and it's going to return to me a JSON object that contains things like, what's the language that this text is in? What are the key phrases that you can find in this text? And then based on those key phrases, it's going to figure out whether this is a positive phrase or it's a negative one. So in this case, it figures out that it's 98% positive. The more you go towards 100%, the more positive it will be. I've built a demo here, a very quick one, where basically I'm scanning all of Twitter, and I'm searching for a certain hashtag, and I'm using logic apps to build that, to listen to new tweets that are being posted, and I'm filtering, I'm taking that text and submitting it to the sentiment text analysis API, and then I'm going to post a message in Slack with that text and the score for sentiment. And Logic App is basically a workflow tool where I can design. I have multiple steps, and it's all visual. So it's super easy to use. I'm going to quickly show you. I have just a couple of more minutes. So this is how I would create. I'm connecting to Twitter. I'm listening for the JSPoland hashtag. And then every 3 minutes, I'm checking whether anything new has been created. And then I'm submitting that text to the sentiment analysis API. And the result to that, I'm going to post it as a message into Slack. These are all connectors that are available in Logic app. And you can see here that last night I was able to follow you while you were having fun at not too late last night, okay, and even this morning. So from now on, I'm going to receive messages about JSPoland. It took me a couple of minutes to create this, and I'm using machine learning. So if you want to try this yourself, if you want to get started with machine learning, I highly recommend you go get started with either TensorFlow.js, which allows you to write JavaScript and build machine learning applications that leverage machine learning in the browser. Or you could use machine learning as a service. So use APIs that have been created by other people that have been trained to do that and can help us include machine learning in our applications. And start small and fun. Build side projects. Enjoy what you're doing. It's going to get you started in a very smooth way. These are some resources that you can use to start learning. The first two links are the application, the Doppelganger application that I've created. And then the next links are to cognitive services and custom vision API. I hope you enjoyed this, and I hope you have a fantastic rest of the day. Thank you.